Hi, I'm Murray Palmer, and we're getting set to do a video on riveting. We're going to be talking about rivet guns, rivet sets, and bucking bars, and how we're going to create a properly bucked rivet. Good. Anyway, let's get on a little bit more onto dealing with rivets now. So we got three different methods of squeezing a rivet, or bucking a rivet, if that's what you want to call it. There's different terms for it, sort of thing. But what we have, this number one up here, hand riveting using a hammer and a punch, I don't even recommend it. The reason I don't recommend it is 90% of us can't use a hammer consecutively and hit exactly the same spot time after time after time. And so what I have, and all the students I've ever taught my entire life, I've said stay away from this thing until you can use a hammer. So they need to become very, very good with a hammer so that you can hit exactly the same spot. So I say don't even worry about it. The second one, driving a rivet with a rivet gun. That's what we're going to do here for 99% of the stuff that we're going to do on the blank. And then there's the squeezers. We've got hand squeezers, pneumatic squeezers. But all they do is they just take this rivet that was here and they squeeze it together. If we're going to use a bucking bar, or sorry, the second, go back to the second one where we drive it, I'll talk a little bit about here in a second of actually how that works. So we've got the rivet guns. This is going to be our most common way of putting a rivet in. And we have been donated some 3s and I think a couple of 4s, what we call 3s and 4 rivets. 3X. Now this 2X, 3X, 4X, this big one up here, that's 7X. 7 of the barrel. That's what they're talking about there. The longer the barrel, the more stroke it has, the harder it hits. Now what ends up happening is you'll need to have, I don't have them, sorry. I thought I had pictures of the snaps. Anyway, in the end of the barrel, right there, you put a snap in there. And that snap has to fit this shape of the rivet or this flat shape of the rivet. Can everybody see that? The flat shape of the rivet. Okay. Now, we make sure that we get the correct size. I'm going to show you how to figure out what the correct size is when you're in the field out there working. You don't have to, once you see how to do it, you just go, okay, I'll just pick it up, test it, I'm good. Okay. Anyway, I'll move on from there. These smaller guns are designed for light work, and that big one up there is for the big heavier rivets. The stuff that we probably aren't going to do too much riveting on. We may do some heavy riveting, but 99% of the stuff that we're going to work with, these two guns here, is more than enough. Yep, go ahead.
Murray, so like the drills, are these all air operated, or are they?
Yes, yep, they're all air operated.
Okay.
You can see they're just missing.
Oh, okay.
Right there. Okay. Is you have a bucking bar in your hand. There's rules and regulations or guidelines, not so much rules, right? Guidelines on what size of a bucking bar to use, what weight of a bucking bar to use for the different sizes of rivets. So for a light rivet, small rivet, you don't need a big heavy bucking bar, but when you get into the really big ones, you do. So what ends up happening is you take the rivet gun, you put the snap in, what they call a snap in, it fits right on your rivet head, so then you keep it on there 90 degrees, nice and straight, and now the bucking bar itself is what does the work. You pull the trigger on the rivet gun, it fires, it puts a shock load into the rivet. It actually knocks the rivet, the bucking bar away from the rivet, and then it comes back in and flattens it. And then, so what ends up happening is you need a number of strokes to shorten that to the correct size. Okay, depending upon the gun you're using and what you get used to. Me personally, I'll count my numbers of hits. Some of the guns run too fast. Some of them are up to 2,500 pounds. My own particular gun probably runs around 1,200 pounds, or 1,200 beats per minute. So I count that. And I'll usually use 10 beats on my gun. It's just what I get used to on my own. I'll set you up. I'll teach you how to feel comfortable with using those so that you're going, okay, I'm good. I can get the same side. I can get the same finish on each rivet as I go along, sort of thing. So that just comes with a little bit. Okay. I think I've covered most of this stuff on the guns. Okay. So this is just, again, how the gun actually works. It's the plunger in them. I've got diagrams that show you exactly how the valves work and all that kind of stuff inside the rivet gun. Not necessarily you need to know. What you need to know is hold it straight. When I say straight, 90 degrees to whatever it is you're riveting, and hold it on, and you're good. And that's all that's really necessary. That's my message to you today, is to learn that. So the gun should be set up a rivet in 1 to 3 seconds. That's how long it takes when you pull the trigger to flatten this, what they call a shop head. Okay, this is a manufacturer's head. This is a shop head. Okay, so we'll talk a little bit in a minute here about the size of that shop head. Okay, but anyway, it takes about 1 to 3 seconds depending upon the size of the rivet that you're working on. So if you get light rivets, it'll be probably 1 second deal. If you're getting really heavy rivets, 3/16 and that size, it's going to take you probably 3 seconds with a heavier gun to get it to set up. You will adjust your rivet gun every time you go to use it. Once you have it set up for that particular size of rivets, you're good for the whole day if you don't change sizes. But when you do change sizes, you're going to have to change how you set your rivet gun up. And that's simple stuff. Again, I'll show you all that. It's just basically putting a snap in it, putting it on something that's relatively hard, like a piece of wood, pull the trigger, and listen to what you hear from the gun, and it'll tell you what it's actually doing. Okay.
Are the bucking bars flat, or do they have some arc of curvature also?
They should always be flat, but you'll get some that are cut at an angle, so you can get into oddball shapes. But you always want to have whatever's hitting here perfectly flat and 90 degrees to that shank. Okay. The curved ones will cause, and we'll get into that in a little bit. It'll cause you a whole mess of problems. It'll destroy what you call your shop head. Now, when we're finished, there's specifications for the size of that shop head to make it be acceptable. And so if it's not within that range, we consider it to be no good, and we would drill it out and get rid of it and put a new one in its place, sort of thing. So you can be, when we get riveting, you might be riveting in a second, go, oh, that's no good. Put your rivet gun down, pick up your drill that one out, get rid of it, stick a new one in, rivet it again. And then if it's good, move on to the next rivet. So that's basically what you're going to be working with all the time that way. Okay, rivet sets and snaps. Again, quality. Spend the money to get quality snaps. If you get poor snaps, you're going to damage your rivets, you're going to damage your skins, and you don't want to do that sort of thing. And now, I'm talking like $25 for a set of 4 or 5 snaps that will do everything that we need. Good enough quality. You don't need anything beyond that, okay? And we'll talk about the different types of snaps as we get further into this. Anyway, one of the things, the bottom line, this working face is set to be smoothly polished. You want to have a flat bucking bar surface that is smooth. Preferably, I like to shine them. I like to polish them, to be honest. If you don't, if there's any kind of damage to that, a nick, a mark, a little hole, divot in it, it's going to show up on your rivet. And we don't want that. We want this nice quality rivet, better than that. We want a nice quality shop head when we're finished, and you can't get that without having a decent bucking bar. Oh, here's the different snaps that we've got. I guess I just had them in a different location. Now, what we've got on here is plastic covers on these things, and so it's hard to tell. This here is basically what we're going to be looking at. And if you notice right there, there's a little divot in there. It fits over top of this universal head, and it fits exactly. Okay? If you put one that's too small on here, you're going to end up with a ring that shows up right in this area here. And what that's called is a smiley. We don't want that because, again, it damages that head. Okay? If we go too big, and that divot that's right there goes over top, and the head comes down and starts hitting the skin, it's going to put a smiley in the skin. And that's worse than putting a smiley in a rivet's no big deal. We drill it out, throw it away, stick a new one in, and we're good. Put smileys on the skin, and we've damaged the skin. And that's not a good scenario. If it's bad, we might end up having to replace the whole skin for that damage that we did. So we got to be careful, that's all I'm trying to say. These ones down here, these are these flat snaps. That's for these flush rivets that we're going to use. They're more difficult to work with because there's nothing. You have to learn how to hold a rivet gun so it doesn't get away on you. And if you don't, it can walk all the way across your work. And again, put smileys in your work. You've got curved ones, like this one up here, you got a curved one for special things. Most of the time what we're going to work with will be this group up here, and what you would end up having 332, 1/8, 5/32, 3/16, and that's 4 sizes. That's all we need to worry about. We just picked up the correct one. Take a rivet, we set the snap up, and we set the rivet upside down, and it'll sit in that little cup. If it sits in there properly, you're good. That's how you test every single time when you're changing your sizes. Once you've done that test once, that's all you need. This is the right size, good. I'm going to rivet this whole row of rivets. I'm good. You've got long ones and short ones, again. Different areas that you're going to get into. We got different length rivets gun. I've got a rivet gun that has a barrel that's this long. Like the whole rivet head of the gun is only this long, and my other one is like this long, sort of thing. So again, for getting into different spots, tighter, and spots that are going to be difficult to work with, and so on and so forth, sort of thing. Okay, universal heads should fit so as to contact about the center 2/3 of the rivet head. Now, we're talking like 2/3 of this, and that snap has to be setting in there. And again, I'll show you when we get rivets and we get the rivet snaps. That's and we don't have to worry about it beyond that. Okay. We talked about the smileys. You'll make a few smileys. Be ready that when you do, you're just going to drill them up. That's part of what ends up happening. We all make those errors. Don't worry about it. If it happens, it happens. We'll show you how to drill it out properly. So you drill it out, stick a new one in, rivet in, and you move on. Flush sets, various sizes. Again, these are a little more difficult to work with, but I'll show you how to control them so they don't walk all over the place, and how to set them up so that they do the job that they're supposed to do. We have in some of these tools we have what we call springs. This is a honeycomb spring, and this is this is set up for this straight snap here. And then we've got this other universal spring. This spring will work on this one or this one, but this spring will not work on that one. Okay, so springs are okay. I don't even have any springs on my rivet guns anymore. I use a bungee cord, and it holds that rivet in. Now, one of the things that we're going to deal with is if this does not have a retainer around there, and you accidentally pointed that at somebody and pull the trigger, that snap will fly up, becomes a projectile. You could kill somebody with them. I've seen them come flying out of guns, and I go like, guys, you're not paying attention to what you're doing. So you've got to have some kind of a retaining system on them, and I use a bungee cord myself because it's fast, and I'll talk about that. And when we get our rivet gun set up, we'll all have them, because there's no springs here. I don't see any of the springs in the new rivet guns that came over from Viking the other day. All right. So bucking bars, various sizes, different materials. Tungsten bucking bars are by far the best ones to use. And the bucking bars, I have one bucking bar that cost me close to $200. Best one I ever had in my life. I love it, sort of thing. But I've also got some that I've made. Most of the ones I have, I've made myself. I have a couple of store-bought ones. Store-bought ones are fine, but I build them to fit my hand. And that's what I'm going to suggest with you guys, is just to get stuff that fits your hand, make up the bucking bar, they're not hard to do, and go from there. And I'll bring some in, and I'll show you how to do it down the road. The big thing on them is this down here. Make sure that you radius all the corners. You don't want anything sharp. Anything with a 90-degree corner can damage your metal. It can damage your rivets, all that kind of stuff. And so we'll just make sure that you have nice radius corners. The other thing too is if you don't have the radius corners, when you're holding your hand gets sore from the sharp edges. So it's nice to have that radius corner just to be comfortable for the day. Here's a bunch of different size bucking bars. In fact, these are, I think all of my own that I have. These ones here, this one here, that one there, this one down here, this one here, are all store-bought ones. All the rest of them I've made, just out of chunks of steel. And like I said, I'll show you and I'll let you use that tungsten one that I've got. You'll be impressed with it. It's half the size of any of these, and it's probably as heavy as that one right there.
What would be the most common one? Or is there a common one for that?
This one's a good one. This one here, it's hard to see, but that one's a pretty good one there. It's not part of this, it's just sitting right beside that one.
Okay.
There's a split there. But this one here, that's for most of the stuff we're going to work with, that's what you want. Okay?
How big would that be?
About
About hockey puck?
just nicely fits in your palm.
Okay.
It's not heavy, it's not real big. Okay, now, here's one of the things that we need to learn a little bit about. So, I'm going to move over here and I'm going to talk a little bit about this thing. So you got your universal head. This is the shank of your rivet sticking out. Now, when we put a rivet into a piece of sheet metal, we need to have 1.5 diameters sticking outside. That tells us exactly how big this shop head is going to be when we're finished. Okay? So, if we have 1/8 inch, we need a diameter and a half sticking out. Okay? So 125 plus whatever, 625, so we're up to 3/16 of an inch sticking out, is what we need to have protruding through when we drill our hole and put it in. So, and you can even, if you can't figure it out, close counts, all right? It doesn't have to be 100% exact. So what you end up doing is you put the rivet through, and then take another rivet and just put it up beside it. On its side, does it look like you got a diameter? Yep, okay. Do I have another half a diameter? Yeah, good, I'm good. Now, when you rivet it up, it goes from being a diameter and a half long to a diameter and a half wide and half a diameter thick. That's the minimum that we need, okay? We can go a little bit less, and during World War II, they used to go with 1/3 of the diameter, okay? Instead of 1/2 a diameter, you go down to 1/3 of a diameter. 1/3 of a diameter is getting a little on the light side. But if you get caught and you don't have the correct length of rivet, you are probably a little bit better off to go slightly short than to go too long. If you go too long, when you get this thing sticking way out here and you put a bucking bar on it, it has a tendency to fold over. And we don't want it to fold. We want it to buck flat and make that nice shop head. Okay? Now, when I put this in here a little bit about cutting tools. When we drill a rivet head off, we've drilled down through the head. The tip's just starting into the shank of the rivet. That's far enough. There's two things we can do. If this was a 1/8 inch rivet, and I used a 1/8 inch drill bit, I can take a 1/8 inch pin punch, stick it in there, snap, and off it comes. Okay, I've got this hand over here. Now, that's basically what we're looking at, is to snap it off. But if we don't have a punch that fits exactly, we can use a chisel to take the head off. Now, a straight flat chisel like this one right here, with sharp square edges, it's dangerous. I don't like anybody even getting close to an airplane with it, because when you go to tap it off, you're going to hit that skin. But if you take a file and you radius that head, all you're doing is you're just rounding this here, and now you've got a nice round cutting surface that when you put it up against the side of this, the center of that curve touches the rivet head, not the outsides. So you've got a lot more play that when you go to hit it, you don't have to worry about scarring the skins underneath. Okay? So that's important as far as I'm concerned. So those are some of the things that we deal with making sure that we've got that cut. Now there's all this other fancy stuff about 70-degree cuts and all that kind of stuff. You're looking at something that works. Don't get hung up on some of these numbers, because that's the ideal thing that we like to teach students in colleges and all that kind of stuff, and they go out in the field. That's what they're shooting for. But at the end of the day, it's got to be, you got to have something that actually works.
Do you have to modify all commercially made
I do.
rivets or cutting tools?
Yeah, I usually do, just because I like it. I want it to work for me. Where I'm going is I'm wanting it to be lazy. And when I say that, not being lazy in the fact that you don't do the job correctly, but you use the most economic way of doing things so that it's easy. Okay? So if I put that radius cutter on there, and now I'm going to take this and I'm going to shear that off. Now there's a chance of me scarring that with these sharp points here, eh? But if it's radiused, less chance, and I'm not going to put it right underneath the head, I'm just going to put it up right about where the middle of that is, right? I'm trying to be steady, but you understand where I'm going, is slightly up, so I don't get
Really
really
did some serious damage there, couldn't you?
huge damage.
Yeah.
So you have, like, you understand exactly where I want to go with
Yeah.
it, because I've seen stuff just completely screwed up, and I don't want to see that happen with this thing, because it just takes so much work to fix it. So anyway, that's where I'm going. These cutting tools, I put the slide up there because there's, just to make you understand where I want to go with it, okay? Okay. You can take a file and you can deburr all the outsides of the skins. And that's what I prefer to use myself, as a file. And I'll teach you guys how to use a file correctly. There's not a lot of people understand that when they're working with sheet metal, how to actually use the file. And I'll show you exactly the proper way to do it. And you'll go, you can say it's fast, it's easy, and you don't damage the skin.
Would you always use a bastard file?
I do.
Yeah.
You know the one that I use is an axe file. 12-inch axe files.
Yeah, they're nice to use.
They are by far the best. Yeah, there's all these different, there's bastard files, there's mill file, and all this different files, all fancy ones you want. The axe files by far work the best, and you got a single cut and a double cut. The double cut gets rid of material in a fairly quick hurry. The single cut, that's fine finish, you're done. So if I'm going to radius corners with this thing, I'm going to use the double cut, flip it over, a couple passes with the single cut, and she's smooth, and it works out really, really well. So here to show you the single cut. This one here that you're looking at, that's what they call a single cut, because there's only one roll. A double cut is when it's electively cut going the opposite 90 degrees to that, and so it crisscrosses throughout the whole length of the file. Oh, there we go. There's a double cut on the far side and a single cut on this side. I'll talk for a little bit. When we're talking about drills, the different materials that we're working with, these here numbers is the speed that your drill will turn. Okay? Now, the hand drills that we've got, they're around 2,800 RPM. That is the absolute max number that you ever want to turn. Absolute max. I turn it about 1/16 of that. I like to see it, I like to see my drill bits working. And I don't care what material I'm working on, either steel, aluminum, brass, titanium, you name it, whatever I'm drilling. I want to see the drill bit going around and starting to cut, and I want to see the material actually come out. I want to see that long tail of material come out with the drill bit. If I'm doing that, I've got exactly the right speed. I can't ask for a better speed. If I go too fast, what ends up happening is I start to chip it. That tail that was curling out of there breaks off, and it just chips out. So the further I get into the piece of material, if I'm drilling something deep, the further I get into it, the more issues I will have if that material starts to break up. And it'll fill the hole up with, and jam the drill bit, and it'll break the drill bit. I can break more drill bits in aluminum than I can in steel, but you can easily break aluminum or drill bits in aluminum. Because what ends up happening is that material, instead of being cleaned out, breaks off and is all down the bottom of the hole, and now it just jams up. It becomes powder. So what you want to do is, if you're drilling deep holes, pull that drill bit out and clean that flute on a regular basis. Just let her go for a bit, clean it out. Patience is a virtue in this aviation game. You know, and I'll tell you the honest truth. When I first got into the aviation game, if I couldn't fix something in 3 seconds with a ball-peen hammer, it wasn't worth fixing. Today, I have so much patience, I just keep going at it and going at it. I have had to turn around and fix so many things because I screwed it up, but I've learned from there. You can't, just don't pull that patience out of your back pocket and keep it in your hand. You need it, trust me.
That's why we're lucky we have you on board.
I've made enough mistakes for everybody, trust me on this one. Anyway, where I'm going, for aluminum, that's it. All those numbers there on the far side, maximum numbers. Never go anything beyond it. And you don't need anything close to that, to be honest. What you need to do is wash your drill bit. Does it actually pull the material out? And if you get a nice even cut, I don't care what speed it's turning out, it's doing the perfect job because it's coming out in one continuous curl. And if you hit that, be happy. If you pat yourself in the back, go get a couple of beers, everything's good. Okay? When we're working with sheet metal, other than small holes, when we get to making large holes, I want to use unibits on sheet metal. If you take a standard drill bit and drill into a piece of aluminum that's 25 or 32 thou thick, and you're trying to put, say, in a, let's go a 1/2 inch hole, what'll happen is that sheet metal, unless it's completely secured down on your table, will walk its way up the drill bit and you'll ruin your piece of sheet metal. But if I take that unibit and I go, okay, there's a 1/2 inch mark on that one right there, and I just take a marker, you know, and highlight it all the way around there, I go, brrr, there it is, my hole's cut, and I got a beautiful hole. Simple and easy, you'll never damage your materials. I recommend these above any follicular bit that there is. Is that the right term? Follicular? Circular bit. Anyway, you know, standard drill bits are only good in for small holes in sheet metal. Once you go beyond, and basically where I'm looking at is about 3/16 of an inch, 1/4 inch at the absolute outside. Anything larger than that, go to the step drill, it's the unibits, and you'll be so happy with yourself after you drill those kind of holes, as opposed to trying to use a standard drill bit and you've destroyed your piece of sheet metal. Okay, some of the things that we have to deal with in our sheet metal dealings is that, number one, the rivets that we put in are for shear loading. They're not a tension load, okay? So the loads that we have, the skins are trying to pull apart this way all the time, okay? The reason we put in a whole mess of rivets is that each one of these rivets, in comparison to the thickness of the material, will withstand so much shear level. And I used to know all these numbers off the top of my head. I've kind of forgotten them a little bit. But a standard 1/8 inch rivet probably will withstand around 800 pounds of shear pressure. You know, that's, you know, I mean, we're talking about a piece of aluminum.
Per rivet.
Per rivet.
Yeah.
Per rivet. Okay, so what we end up doing is when we do a repair, we want to use whatever the manufacturer did for a pattern. Okay, so if they put in, you know, in 5 feet, 300 rivets, we want to go in exactly the same spot as what they did. We do not want to change that. It's not up to us to make that decision, because what they have done is they figured out that what we want to have happen is that we want the rivet to shear before we tear the skin out. So if we got a big load on the skin, and the skin actually pulled out, and there was a hole, like all the rivet holes were stretched or torn right out, and there were still rivets in there, that's a bad thing. We want it to go the other way. We want the rivet to actually shear first. That's the whole idea behind the strength. And there's been a lot of testing done to figure out exactly how much you need to have for the rivet spacings and the size of rivets for the thickness of the skin and so on and so forth. So those are some of the things that we basically have to do. We'll always go with what the manufacturer did unless we're going to do a repair. There's going to be what they call a structural repair manual, which will tell us if it's a repair, what we can do and what we can't do. And if we don't have the structural repair manual, we can go to what they call AC43, which is another publication which most of the structural repair manuals came from. And we will use that information out of those to create the specific patch or repair that we're going to do. Okay? Now, so here's the idea. We want to get the correct size of rivet for the thickness of the material, sort of thing. Something like this, not really acceptable. But where I'm going to go is the manufacturers figured this out a long time ago. There's charts out there. We can use the charts if we have to, but we don't have to. We just go with what's been set up, okay? And we'll figure that we need to use the correct materials, correct size. When we're doing a repair, we want to make sure that if that was a crack in the skin, and we're going to put a patch over top of that, a couple of things that we'd have to do. We'd have to stop drill this on each end with at least a 1/8 inch size rivet, or drill bit I should say, so that the stress risers goes into the hole, and the stresses then just go round and around the hole. Okay, so now when we put a patch over top of it, like this, we want to make sure that the loads on the aircraft, the flexing loads, the twisting loads, all of that kind of stuff that the aircraft is going to experience in the air, that the load is going to go through the repair and not cause any more problems. So the patch that we're doing, and we shouldn't call them patches because patches isn't a good word, but the repair needs to be the correct size, big enough to carry the load, enough rivets in it so that it won't, so that it will carry the load, and that we've got enough overlap so that our repair is not questioned in any way, shape, or form. Okay? So those are things that we do, and we'll talk about those. If we're going to do a repair, there's multiple different styles of repairs. I'll teach you all the correct ones and how to use them. So some of the stuff that we want to basically deal with, if you're doing anything on an airplane, you don't want to see this kind of a corner. Okay? That's stress risers. Those sharp corners are no good. This here is what we want to see. Smooth stuff around. If it's blended out, that's not a big deal. Okay? If we've got tiny little cracks in skin, we can blend that out by doing it in that manner. And we'll talk about that. We can get rid of some of the corrosion that we're going to work with in specific thicknesses of skins. But we have to be concerned about the thickness of the skin. Legally, the skin needs to be at least 40 thou thick before we can start to blend away the surface, and we can only take so much away. Now, if we blend this surface away, remember, there was that 2/1000 of an inch thick skin, or pure aluminum on the outside, right? If that goes away, now you're down into that alloy, and it'll corrode quite easily. So you need to, if that does get out of there, be taken away, you have to prep it. You've got to use the proper materials, the acid etches, the allodynes, the primers, and paint, and all that kind of stuff. Anyway, stuff can be fixed where you don't have to replace everything, but it's going to be small, not large areas. Okay, again, this here's just say a crack in a piece of skin that we find. This used to be, at one time, how they'd do a repair. They'd just go to the end of the crack, drill a hole in it, and then that stress would go into that, and the stresses would just go round and round in the hole. But that's not the way it's accepted today. Now you've got to actually put a patch over top of it, sort of thing. So again, when we run into something like that, I'll make sure that we talk about that. So there's the different properties of the metals, and that's why, and the manufacturers choose all this stuff. This is how they determine what we need to use, the correct type of aluminum. And there's multiple different styles, different types of aluminum that we will use, varying ones on this machine. Most of it will be the 2024.
What's ductility?
Ductility is the ability to bend and straight. It's something like malleable, but ductility means that you can put it through a die and you stretch it out into a wire or a tube. That's ductility. Okay? It has to go through a die, it gets made smaller, gets stretched. Okay? So these are the important components of what we basically deal with: tensile strength, yield strength, shear strength, and bearing. Okay. These aluminums So, like I said, there's all kinds of different things that you're going to find in the aluminums. There's a whole mess of different alloys. When we get into it, these alloys here, I would call the 1 series, that's what they call pure aluminum. That one, and every piece of aluminum will have a designation. And then for this one, it could be a 1000, and it's absolutely pure commercial grade aluminum. It's soft, it's easy to drill, but actually it's hard to drill because it'll fill your drill bits out. Now, what we normally work with is this 2000 series. So when you hear me say 2024, the first two digits is the 20 series, the 2000 series. The 24 means that there's copper in it. If it's a 3 series, there's magnesium in it, manganese I should say in it. 4 is silicon, 5 is magnesium, 6 is magnesium and silicone, 7 is zinc, 8 is other elements. So we may end up using some of the 7 series when we're working on the airplane. Okay.
It intensifies, it gets harder as you go down. doesn't it?
Yep, it sure is. Real hard in
Yeah.
comparison. Yep, right. You're 100% correct on that one. Totally correct. Okay. Where I want to go is we don't have to worry about too much about figuring out what we need. I'll keep everybody straight. Because what I'll end up doing is I'll go to the book, or whoever is going to do a replacement of a skin or repair or whatever it is, they'll go to the book and say, this is what the material was in that spot. We make sure that we'll use that. We're going to do some substitution on this because some of the stuff that was built during World War II is not available today, and we have to do the repairs and resurrect this aircraft with today's standard. We can't go back to 1945 and say, oh, this was done in 45. It was, but they won't allow us to fly it if we do it in that manner because they found that there were certain things that didn't work well. And so since then, we've come up with better ones. All right, so what we're doing here today is literally building ourselves a rivet gauge so that we understand the length of the rivet, that when we put it into our piece of material, how long it has to be. And after we have bucked that rivet, we're going to be able to measure the depth and the width of the head so that we can determine the shock head size. And what we're going to do is we're going to build it to the dimensions that are on this piece of paper here. That's basically a finished one right there. Absolutely.
Here, hold on. Go ahead.
All I'm doing is just measuring this right at the moment to make sure that I'm square. I'm using parts of the caliper, and I'm measuring for length. And everything works out pretty good. It's fairly square, so I'm happy.
Can you check the edges for me to make sure it's right? That's what I was
Okay. So what you want to do is for the edges. All we're going to do is just get rid of that.
Yeah. So can you
Yep.
check?
Oh yeah. Yep. So that's
I think
as long as you've done that. Oh, you got one there. Okay. The file's not your friend, but I'll get it. Yeah. That's right. Once you now.
Go ahead.
You can file them in.
Yep. Okay.
Okay. Now, what we need is the numbers. So, once you got them down here, there's your dimension, 136 to 1.136.146. So, what I'm doing, I'm just going to split that in half. Right now, it's set at 1.410, which is roughly halfway between those two numbers, right? I'm giving myself a little bit of fudge room to what I'm doing. So this measurement is going to be from there to there. You understand where I'm going with this? So what I'm going to do this, I'm going to say, okay, this should be the side that we're going to work on this beginning, okay? So let's just go this corner up here. And a slight scratch mark. There, that scratch mark is part of it, 4222052. So we'll just go with this and go 4 or 5 watts to go. So you get 0.0 and we'll go down to 4.
Start again.
All I'm trying to do is replicate the numbers that we have on our drawing onto here so we know which corner we're going to create the specific size slot. So we're going to start with 3, 4, 5, and 6. Basically 3, 4, 5, and 6. You know, okay. Yeah, you don't have to be right on top of the hole, but close, fairly close, and you should be good. Yep, good, ideal. And so 4, just as we basically got on this drawing right here. So we're doing that one there. Yep, and then we'll go to 5.
And why again are we numbering them?
So you know what size of a hole that you're going to be drilling, and you know what size of a rivet that you can put into it. It's just a guide, and it becomes one of those things. We'll talk when we get further into the kind of the riveting thing. I'll talk a lot more about the sizes and making sure that you understand them. Remember, perfect. Yeah. So we've got some more. We don't have any 3:30 seconds.
There. That's mine.
When you drill a hole, what ends up happening, we talked about this, about stress risers, right? And you can actually see the stress risers on here if you get looking. Yeah. So you see them, you can see them there? Every piece of skin that you're going to work on, you're going to do this as well. So you're going to do probably 3 passes at least with a file on each edge, okay? The end like that, the edge like this. Now, you flip the other side, the edge like that. But you got every single edge that you're working on, and you got to kind of keep track of where you've been, so that you don't don't miss anything, sort of thing. Okay. Now, the reason I'm doing it on this is it's not that this is going to become a problem, because it's not going to have a load on it. But I'm just showing you how you're going to end up doing it. So at the end of it, you want things to be smooth, so there's no. So now what we want to do is we want to mark that in relation to the direction it should be on here. Right. So this is a dimension B. So dimension B is going to go up and down on this corner, right? Yes. So now what I would do, I would take this, knowing that this is the top corner, I would put this in like so, and I would score it just like that. Okay, that's how now, now, the next one, you go to
Back to A, 0.1136, or say 0.114.
Yeah.
114.
114.
Ready? Running. Okay.